A question is typed into a machine. The answer appears in seconds. It is smooth, it is confident. It is beautifully written. It sounds like it came from an expert. There is only one problem. It is wrong. This is the moment many people lose trust in AI. They see one confident mistake and say, AI cannot be trusted. AI makes things up. AI is useless. And they are not completely wrong. AI can hallucinate. It can create answers that sound true, even when they are not. But what if the biggest misunderstanding is not that AI fails? What if the biggest misunderstanding is why it fails? Because in many cases, the problem is not simply the model. The problem is the missing machine around the model. To understand AI hallucination, we have to go behind the screen, behind the chatbot, behind the polished answer, behind the illusion of intelligence. Because what looks like one simple response is supposed to be the result of an entire system. And when that system is missing, the model is left to do something dangerous. It guesses. Imagine a woman named Sarah. She booked a flight months ago for a family trip. But now, something has changed. She cannot travel. So she opens an AI assistant and types a simple question. Can I cancel my flight and get my money back? Within seconds, the AI replies, yes. Many airlines allow cancellations within certain conditions, and you may be eligible for a refund or travel credit. The answer sounds helpful. It sounds calm. It sounds professional. It even sounds like it understands airline policies. So Sarah relaxes. She trusts it. She tells her family, I think we can get our money back. But there is something Sarah does not know. The AI was never given her actual ticket. It did not know whether the ticket was refundable or non-refundable. It did not know the airline. It did not know the fare class. It did not know the country of travel. It did not know how many days were left before departure. It did not know whether she booked through the airline or a third-party website. It did not know whether special cancellation rules applied. The answer sounded right, but it was not grounded in the right facts, and that is the dangerous part of hallucination. Not that AI is always wrong, but that AI can be wrong beautifully. It can give an answer that feels useful before it has earned the right to be trusted. Most people meet AI in its simplest form. They ask a question. The model gives an answer. That is the experience millions of people know. But this creates a dangerous misunderstanding. People begin to think, this is what AI is, a box where questions go in and answers come out. But a raw language model is not a full business application. It is not your database. It is not your company knowledge base. It is not your policy library. It is not your security system. It is not your document approval process. It is not your quality control department. It is a language engine. And a language engine is powerful. But power without control can become risk. Nobody buys an engine, places it on the ground and says, now I can drive to work. The engine may be powerful, but it is not a car. To become useful, it needs a full system around it. Wheels, brakes, steering, sensors, fuel, navigation, a dashboard, safety testing, maintenance. AI is the same. The model is the engine, but the Gen AI application is the car. And hallucination often happens when people try to drive the engine. A large language model is very good at language. It can explain complex ideas. It can summarize long documents. It can compare options. It can draft emails. It can translate technical language into simple words. It can reason through patterns. It can produce answers that feel human. That is its strength. But it is also why hallucination is so dangerous. Because when the model is wrong, it may not look wrong. It may not sound uncertain. It may not warn you. It may not say, I am filling in missing information. Instead, it may speak with confidence. And confidence can create trust, even when the facts are missing. The model does not automatically know your actual airline ticket. It does not automatically know your latest company rule. It does not automatically know which document was approved yesterday. It does not automatically know which policy changed last month. It does not automatically know which user is allowed to see which information. If that information is not provided to the system, the model may still try to answer. And when a model tries to answer without enough trusted evidence, it may begin to invent. That invention is what we call hallucination. Think of a very smart friend, someone who is excellent at explaining things. You ask, "Can I cancel my flight and get my money back?" But you do not show your friend the ticket. You do not tell them the airline. You do not tell them the fare type. You do not tell them the departure date. You do not explain whether you booked directly or through a third-party website. You do not say whether the ticket was refundable or non-refundable. You do not mention whether the airline changed the flight. You do not say whether there are special rules for your route. Your friend may still try to help. They may say, "Usually many airlines allow cancellations, but you may receive a travel credit instead of a refund." That answer is not foolish. It is reasonable. But reasonable is not the same as correct. For this exact ticket, this exact airline, this exact route, and this exact timing, the answer may be different. The friend did not fail because they lacked intelligence. They failed because they lacked context. This is what happens with AI. When we give AI a serious question without serious context, we are asking it to sound smart in the dark. And sometimes it does. To make AI reliable, we need the hidden machine, the part most users never see. Before a good AI system answers, it does not simply send the question to the model. It prepares, it checks, it searches, it filters, it verifies. A production Gen AI application asks, what is the user really asking? Is the question complete? Which airline are they referring to? Which ticket type applies? Which date matters? Which policy document is current? Is the user allowed to access this information? Is the question too risky to answer automatically? Should a human review this? Only after these checks does the system begin to gather evidence. And that changes everything. Because the goal is no longer, make the model sound smart. The goal becomes, make the model answer from evidence. The first part of the hidden machine is the data pipeline. This is where raw information becomes usable knowledge. In the real world, data is rarely clean. Documents are outdated, tables are broken, PDFs are scanned poorly, old versions sit next to new versions. Drafts look similar to approved documents. Some pages are missing, some rules are buried in footnotes, some information is duplicated, some information contradicts other information. Think about airline refund rules. There may be one rule for refundable tickets, another rule for non-refundable tickets, another rule if the airline cancels the flight, another rule if the passenger cancels, another rule if the ticket was booked through a third-party site, another rule for international travel, another rule during special disruptions. If all of that information is messy, outdated, or poorly organized, the model may misunderstand it. So the pipeline prepares it. It validates the documents. It removes duplicates. It separates drafts from approved content. It repairs broken text. It preserves tables. It labels documents with metadata, airline, ticket type, route, date, refund eligibility, approval status, version, audience, security level. Then it breaks large documents into smaller sections the model can actually use. This step may not look exciting, but it is one of the most important parts of reliable AI, because the quality of the answer depends on the quality of the information that reaches the model. The audience sees the final response, but the truth is shaped much earlier, in the pipeline. Once the information is prepared, the system needs a way to find it. Traditional search looks for matching words. If you search for refund, it looks for the word refund. But humans do not always ask questions using the exact words in the document. A traveler may ask, "Can I get my money back?" Another person may ask, "Will they return the payment to my card?" Another may ask, "Do I only get credit?" The airline document may say, "Refund eligibility," or "Travel credit," or "Fare difference," or "Cancellation penalty," or "Non-refundable fare." Different words, related meaning. This is where vector stores become important. A vector store helps organize information by meaning, not just by exact keywords. the system turns text into embeddings. Embeddings are mathematical representations of meaning. They allow the system to compare the meaning of a question with the meaning of document sections. So even if the user says, "Can I get my money back?" the system may find sections about refund eligibility, travel credit, non-refundable fares, cancellation penalties, airline-initiated schedule changes. The vector store becomes a library of meaning, not just a library of words. And for AI, that is powerful, because before the model can answer from evidence, the system has to find the evidence. But storing knowledge is not enough. A library is only useful if you can find the right page at the right time. That is retrieval. Retrieval is the process of deciding what information the model should see before it answers. And this decision is critical. Retrieve too little, and the model may miss the answer. Retrieve too much, and the model may get confused. Retrieve an old document, and the model may answer with outdated rules. Retrieve the wrong airline policy, and the answer may be wrong. Retrieve a policy for refundable tickets when the traveler has a non-refundable ticket, and the answer may become misleading. So good retrieval design asks, should we search by keywords? Should we search by meaning? Should we combine both? Should we filter by airline? Should we filter by ticket type? Should we filter by route? Should we filter by booking date? Should we filter by cancellation reason? Should we rank the best sections higher? Should we include tables? Should we ask the user a follow-up question before answering? Should the system refuse to answer if the evidence is weak? This is where real Gen AI engineering begins. Not when the model writes the final sentence, but when the system decides which facts deserve to reach the model. Only now does the model speak, but it is no longer speaking alone. It has context, it has evidence, it has instructions, it has boundaries. The system tells the model, answer only from the provided context. Do not guess. Do not use unsupported assumptions. If the answer is not available, say so. Cite the source. Use the correct tone. Respect the user's role. Avoid exposing restricted information. Now the model is doing what it does best. It takes complex evidence and turns it into clear language. It explains, it summarizes, it connects ideas. It produces a human-friendly answer, but this time, the answer is grounded. This is the difference between a raw AI response and a production Gen AI response. The raw model says, "Here is what might be true." The grounded system says, "Here is what the evidence supports." In a reliable AI system, the best answer is not always an answer. Sometimes the best response is, "I do not have enough information," or "Please provide the airline, ticket type, and departure date," or "The available documents do not confirm refund eligibility," or "This should be escalated to a human support agent." That may sound less impressive, but it is far safer. A weak AI system tries to answer everything. A strong AI system knows when not to answer. This is one of the biggest differences between a chatbot demo and a serious business application. In high-risk situations, refusal is not failure. Clarification is not weakness. Escalation is not a defect. These are signs of control, and control is what turns AI from a toy into a tool. So are the critics right? Yes. AI can hallucinate. It can be risky. It can mislead people. It should not be trusted blindly. But many critics stop at the surface. They see a raw model fail and conclude that AI cannot do serious work. That is like watching a student fail an open book exam when no one gave the student the book. It is like blaming a chef for a bad meal after giving them spoiled ingredients. It is like blaming an engine for not being a car. The real lesson is not, AI is useless. The real lesson is, raw AI is not enough. For serious work, AI needs a system, a truth system, a control system, an evidence system, a safety system. That is the hidden machine. This is the line that changes everything. Hallucination is often not just a model problem. It is an architecture problem. If the model has no trusted data, it may guess. If the model gets the wrong data, it may answer wrongly. If the model gets outdated data, it may repeat outdated rules. If the model gets messy data, it may misunderstand. If the prompt is vague, the answer may be vague. If there are no guardrails, the model may go too far. If there is no evaluation, nobody knows when it fails. But when the system provides clean input, trusted context, strong retrieval, clear instructions, access controls, source citations, evaluation, and human review when needed, AI becomes something different. Not magic, not perfect, but useful, controlled, measurable, trustworthy enough for real work. This is why building Gen AI applications is not just about calling a foundation model. Calling the model is the easy part. The real work is everything around it. Understanding business requirements, choosing the right model, preparing the data, creating the embeddings, designing the vector store, building retrieval mechanisms, writing prompts that control behavior, applying guardrails, checking permissions, testing outputs, monitoring failures, updating documents, measuring quality, escalating risky cases. This is why modern Gen AI development feels different from traditional application development. The application does not just process data, it helps produce judgment-like responses. And when software begins producing judgment-like responses, the architecture matters more than ever. Because every answer has a chain behind it, a chain of data, a chain of retrieval, a chain of instructions, a chain of controls, a chain of accountability. Break the chain and the answer becomes risky. Strengthen the chain and AI becomes useful. Now return to Sarah. She asks again, "Can I cancel my flight and get my money back?" But this time, Sarah is not using a raw chatbot. She is using a properly designed AI assistant. The system does not rush to answer. It asks for the airline. It checks the ticket type. It confirms the departure date. It asks whether the airline changed the flight or Sarah is choosing to cancel. It checks whether the booking was made directly or through a third-party site. It retrieves the latest approved refund policy. It filters out old versions. It finds the relevant sections on refundable fares, non-refundable fares, travel credits, cancellation fees, and schedule changes. Then it generates a response. Based on the ticket details and the current refund policy, this ticket may not qualify for a cash refund, but it may qualify for a travel credit. If the airline changed or canceled the flight, different refund rules may apply. It cites the source. It highlights uncertainty. It recommends contacting support if special conditions apply. This answer may not be as fast as a guess. It may not be as flashy, but it is safer. It is grounded. It is useful. And in real life, that is what matters. AI is not useless because it hallucinates. AI is powerful because it can reason with language, but that power must be controlled. A model without grounding is like an engine without brakes. Fast, impressive, dangerous. A model inside a well-designed system becomes something different. It becomes a tool that can search knowledge, explain complex rules, support employees, summarize documents, assist customers, and speed up work. Not by replacing truth, but by connecting language to truth. That is the future of AI. Not random prompts, not blind trust, not magical thinking. The future is grounded systems. Systems that know when to answer, when to ask, when to cite, when to refuse, when to escalate. Systems that combine human judgment, trusted data, and machine intelligence. Because AI hallucination is not the end of AI. It is a warning that power without architecture is risky. A warning that intelligence without evidence is not enough. A warning that the real future belongs not to those who simply use AI, but to those who understand how to build it. AI is not magic. AI is a system. And the people who understand the system will build what comes next. That is the difference. And that is the hidden machine behind reliable artificial intelligence. If this changed the way you think about AI, then this channel is for you. Here, we do not just chase AI hype. We break down how AI really works, how Gen AI applications are designed, how models, data, retrieval, guardrails, and architecture come together, and how you can understand the future before it becomes obvious to everyone else. So subscribe to the channel, because the next wave of AI will not belong to people who only know how to prompt. It will belong to people who understand how to build. Subscribe now, and let's learn how to build the future of AI, one system at a time.